Good afternoon, everyone, and welcome to today's webinar. We'll be getting started in just a few minutes. Good afternoon, everyone, and welcome to today's IIP tips and tricks session using Sniffers to troubleshoot a PAX DICOM error. Your host for the IIP series is none other than Herman Oosterwijk, an imaging informatics leader with extensive background in implementing healthcare imaging and IT solutions. Herman serves as the EHR, PAX, DICOM, and IHE instructor, in addition to being the overall project manager and primary consultant for OTEC. Ladies and gentlemen, Herman Oosterwijk.
Wow, thank you, Bradley. Always impressed with your great introduction. Appreciate it. So let's talk about IIP tips and tricks and using a DICOM sniffer to troubleshoot errors. And I think some of you might have experienced this, what they call the infamous DICOM error that will appear on the CT scanner, on the workstation, or on the PACS, and then not knowing what to do next, right? You might look at a log file if you have access to that. And then in many cases, it ends up with finger pointing between, oh, it was the CT. Oh, no, the CT guy says it's the PACS. Oh, no, it is the viewing station. So a DICOM sniffer is the solution, right? So what we're going to do today, we'll talk a little bit about the, get a little bit fresher on networking, just a couple of slides. So when we talk about packets, you know a little bit what we're talking about. A little bit of DICOM refresh. I'll do a high level overview a little bit about the session that you always should be able to recognize when we look at the DICOM sniffer information. We'll show you how to use, how to set up the Wireshark. It's very simple, actually only 2 or 3 things that you have to set up. And then we'll do some playing, we'll do some hands-on, and we'll go relatively quick. And so the good news is that Bradley promised that after this presentation, he will archive it and will make it available freely to everybody. So when I go a little bit too quick and maybe with a couple of mouse clicks that you can go back and stop the video and see exactly what I've been doing so you can practice it yourself. And then we have some time for questions and discussion. So a little bit about DICOM networking. So basically when we go and we will see the sniffer. So what is a packet sniffer? Packet sniffer sniffs packets. Right? Misty was even asking, so what is a sniffer anyway? Well, it's like a dog sniffing, capturing packets. And on the lower level, particularly if you have a connection, a fixed connection, there's the Ethernet frame, and we'll see that later on. So there's the Ethernet frame. The Ethernet frames are encapsulated in a TCP/IP frame, and all of those are encapsulated in a DICOM packet. Yeah. So if you go to the top, see, look at the top of my presentation. My slide. Let me get my pointer here. So there's a node called the DICOM Protocol Data Unit, PDU, Protocol Data Units. That's the thing we are going to be looking for. A Protocol Data Unit is a packet, an application level packet. And these application level packets are encapsulated in the TCP/IP with the appropriate TCP/IP frame information. And the TCP packets are then encapsulated in an Ethernet frame with the appropriate Ethernet frame. Or if you have a wireless connection in whatever the wireless protocol is. Yeah. So what we're talking about is an encapsulation of these different packets, and we're not interested in Ethernet or TCP. Networking people love to look at TCP/IP frames because they're looking for congestion, for drop packets and all that stuff, but that's not our area of focus. What we're going to do is we're going to take these Ethernet frames, unwrap them into the TCP/IP frames, and unwrap them. So we're going to look at the DICOM protocol data units, because that's where the information is that we're looking for. Right? So the DICOM protocol sits on top of that TCP/IP, right here, DICOM upper layer protocol. And basically what we will be seeing is we will see different parts of the protocol. We'll see the session, part of the protocol and establishing a connection. what I'll explain in a few minutes. There's always 3 steps. You establish the connection, you do your job, and then you release it. 1, 2, and 3. That's part of the DICOM Session protocol. We'll be able to recognize those. There's a presentation part, and the presentation part actually is part of the negotiation that happens when an association or connection is to be established. So basically the DICOM SCU, service class user, will say, I like to propose the following presentation context with typically 2 components. What I want to do, for example, I want to send CT images, and how to encode it, maybe JPEG compressed, right? So we have the presentation layer, and then we have the association control service elements right here. This is basically the commands, the cstore, cfind, cget, cmove, associate request, release, and so on. So those 3 components is what we're going to see when we're looking at the protocols. So DICOM protocol. Like I just mentioned, we have protocol units, PDUs, protocol data units, and the commands that we will recognize at that level when we look at a sniffer are the following. We will see always an associate request. That is when a device wants to initiate a connection. So we always see an associate request. Then it will either be accepted or rejected. Hopefully, supposedly will be accepted. But, you know, what do we do? This troubleshooting, because we want to find out if it does not work. And in that case, it will be rejected for whatever the reason is, that rejection. That for whatever reason, the SCP says, I don't want to talk to you. Right? And it could be because it was the SCU, the sender, the client is proposing to send maybe a structured report or a dose report that it doesn't understand. Or it might actually propose a wavelet compression scheme that is not part, in its capabilities of the PACS system. So those the 3 commands that are part of step 1. Step 1, associate request, either reject or accept. Then we get the second part of the protocol is the exchange of the data. PData, protocol data unit, so it's a packet, a DICOM protocol packet, application level protocol that says, I want you to do a store, or I want you to do a move or get, or whatever it is that the application wants the DICOM application entity on the other side to be doing. That's step 2. Step 3, after we do our connection, basically the CT, for example, sends a series of images, and then it has to close it, right? It's like making a phone call and you start calling, and in the old days we had to put down the phone, but now we have to push the button, to hang up the phone. But basically, if you don't do that, then your connection will be still open. So we always need to have a proper release. So we have a release request and a release response as well. So that's step 3. Anytime there could also be an abort. Now, when you see an abort, there are actually a couple of areas where we can see an abort. And so I should talk a little bit about that because I've seen problems with that. So what is an abort? That's a hard reset. So sometimes, let's say we have a portable unit in an OR, and the portable unit, maybe it's connected to the wire. Very likely it's wireless, but assume it's connected to the wall, right? Because maybe there was no good wireless reception there, and they have a connection to the wall, and they send images and they pull the cable because somebody says, hey, come here, I need to do another examination on the other side. Pull the cable in the middle of the transaction. When the image is being sent, it stops. So what does the PACS do? Is listening, and at a certain point of time, it will time out. So how does it do that? Send a reset, an abort, because otherwise these association will be hanging open. So an abort is typically done, when at the time of a timeout, number 1. Number 2, I've seen quite often that an abort is done by standard by any device, but before it starts to talk to connection. So it might do, okay, reset, and then I'm starting to talk, just to make sure everything is okay. So I've seen that happening as well. I've also seen aborts in the middle of a connection, and that's, of course, bad news. And that's why I kind of highlighted a little bit. If you see an abort in the middle of a transfer, spurious abort, spurious reset, and then we have problems. I've seen that, I think, was in one of the hospitals in Boston somewhere, where occasionally in random times, the study would not come across. And again, using a sniffer, we could find out, okay, after 25 images, an abort. So now, of course, the vendor said, no, it's not a problem. But now using the sniffer communication, we could say, why is it that you sent a reset? We do, really? Yeah, look right here. So this is the abort. So it's like a reset for good purposes and bad purposes sometimes used. So there's a picture of those 3 steps that we'll be able to recognize, right? So step 1, when we make a DICOM connection, we do a propose with an associate request, a connection, step 1. And then we get a response back. Then we get step 2, we do the job, transfer the information, and step 3 release. Now, why do I put these question marks here? I put these question marks here because that is exactly the area, that these are the points, these are the transactions that is going to have our focus. Because what could happen when something goes wrong? Either at step 1, I try to propose something that is rejected. So we look at this question mark, say, is everything accepted? There are no problem here. So is the error occur at step 1 when I want to do something, I want to propose something, maybe I want to send structured reports that are not supported, those reports, CAT results, whatever it is, or an enhanced MRI that is not supported. So do I want to support something, or I want to maybe send something in compressed format that is not supported by the receiver, right? Now, after this works, step 1, even the step 1 typically works one time, unless there's a software change or an upgrade or something, it should typically work the second time, or unless the user on the sender side selects something. You might select maybe instead of a single frame, a multi-frame, and then by default, maybe the unit is programmed to send JPEG compressed, and that might not work then either, right? So that's typically not, after the successful connection, everything is installed. That is typically not the area where you're looking for when you do troubleshooting. The second area is where we're looking for is when a communication, when a command is sent, whether it's a store or find, a get or move, whatever it is, and then an error comes back. Yeah, an error would be, well, could be like, okay, I couldn't figure it out. My disk is full, hopefully not. But for example, if we send images to a workstation, it might say I don't have enough space. There's a pretty typical error, or there could be something going on with the image itself, because what most PAC systems do, they look at the images, they do a quick inspection, they say, okay, oh, bad news, I'm not going to accept it, error back, right? Most of the time, if it's not too bad, then the PAC system will actually put it in the lost and found file, or the unverified, or the broken study file. But it could be, it's not uncommon that the PACs would complain about it, says, no, this is a problem, I'm not going to accept it. It's your problem to fix it. Yeah. So that would be the second area where we were looking for. And I'm going to show you actually also in the sequence of the commands exactly where to look for. So those are the 3 commands, the 3 sessions, the 3 parts of the session protocol. So we have the request protocol unit, and then of course we have the message exchange. Now, before we do any communication, of course, we typically do a ping test, right? And I just wanted to, because sometimes when we have a connection issue, it's not necessarily always the DICOM connection, right? So make sure that your network is working. And of course, you can do that very simple by doing the ping. And also, you have some other ones. Some other very useful commands. And I have to tell you, I mean, I've done this now for probably 25 years or so, and I still make errors, right? Because we're human. Right? For example, about just last month, I couldn't figure out why I couldn't get my packs starting up, and I was having 2 applications listening to the same port, right? So these commands, in this case, when we do a netstat, we can see all the port numbers that people are listening on. Say, okay, oh, I forgot that the other application was already listening, 11112 or 104, whatever it is. So these are very common. I use it very regularly, and like I said, people might make mistakes, and sometimes you forget that you have another application on the same port number listening, and you configure something, and then you figure out why doesn't it work. So make sure that you know your TCP/IP commands, right? So that you can at least troubleshoot the networking, because if the network is not working, then you don't need to necessarily go to the next step. So, okay, so we have all these commands. We assume the network is perfectly right. We have connection, right? We did a ping to the packs. So what are some of the tools in case we have problems? Now, there are actually three different kind of tools, and we're going to only talk today about one of them. It might take some other session to talk about some of the other ones, but of course there's passive tools, and this sniffer is a passive tool. What does that mean? It just listens. So it does not interact, it does not interact, it does not actively engage with the exchange of the information. Now, what is the good news about that? Because it doesn't actively interact, that means that you don't potentially impact the behavior. Because if you have what I thought the second one, an active test tool, for example, you send images to the packs, you said that doesn't work. Let me send an image from my laptop to the packs and how it works. Well, yeah, of course, because it could potentially behave quite differently. So that will be an active test tool, having another sender where you want to send images. But a passive test tool, so the nice thing is that it is totally non-intrusive. It's really sniffing. It's just listening at the packets, grabbing them, right, as fast as it can, and storing them and displaying them. So it's completely passive, right? So if we listen in and we capture the packets. There's also tools, I just want to make sure, because everybody should have those three kind of tools. You should have an active test tool. Okay, so order some other DICOM receivers and senders that you should be able to work with, some simulators. And you should have the passive test tool. And you should also have in your pocket or at your availability validators. You know, if you have a problem with an image and you cannot figure it out why the image is rejected, you need to be able to run a validator that says, okay, oh, the study or whatever the study or the institution name was too long, too many characters, and that's why it was not accepted. Or there's some, and again, so you need these validators. I mean, I do this for 25 years, but I don't know the DICOM standard. I don't know that in my brain. I don't know if I look at a header, what might be wrong or not. I know the 10 most frequent problems, but there's sometimes such small issues that you only can't figure out with a validator. Okay, so what we're using a passive test tool, and basically what happens if a connection has problems, we connect the network sniffer. Oh, I'm sorry about the noise. So we have a network sniffer. The network sniffer will capture the packets that go between those two devices, right? Basically, what happens is the raw data is interpreted. So basically, it recognizes there's a packet in there, an Ethernet packet, and then it strips off the header and the trailer, and then becomes a TCP/IP packet. It strips off all the information, and then it makes a DICOM packet. So it interprets the DICOM information. So the nice thing of Wireshark, because everybody in networking uses packet sniffers. If you talk to the IT guys, the networking person, they have packet sniffers all over. They have it on their routers and that's how they manage the network, because they need to know if there's somebody blasting, some virus is going out, or they want to make sure that they track if the images suddenly not going to the packs, but suddenly going to Russia or whatever, they track that, right? So they want to make sure, so they look at the packets all the time. But what Wireshark does, it has an interpreter. So when it looks at a TCP/IP packet, it can translate the DICOM information. For example, because think about it, this is just when we have a C-store, a DICOM command C-store, we call it a C-store, but it's just a matter of interpreting that code, which is 001 means C-store, 002 means C-find. So it will take that code and interpret that this is a C-store. And it will interpret that and say, okay, here's my patient name, and here's my patient birth date, here's my patient sex. So the good news is that you will be able to look at complete image metadata and all the commands, because Wireshark has a plugin for that particular protocol, in addition to lots of other protocols, right? But as of now, we're really interested in DICOM. Okay, another thing I have to highlight to you, there's also so we're using Wireshark. There are also other tools called DVTK. It's a network analyzer, DICOM validation toolkit. And they actually incorporated the Wireshark as part of the validator pool. And actually what you can do, you can actually grab the packets, upload it in DVTK and do the validation. Okay, so how does it work? So we have a connector, sniffer, right? What you typically would do, you would connect it to a listening port, right? Or you can actually connect it to a hub. Now, what is a hub? A hub is a very unintelligent switch. What I mean, unintelligent switch? So let's say you have a connection between a CT scanner and a workstation, and the hub, let's in this case is a 4-port. Every port shows all of the information, right? So you can connect it to one, you can connect the cable out of the wall. If you can't take the cable out of the wall, you can take the cable out of the wall, put it in the hub, put from the hub back to the wall, and then you connect your PC, your service PC there. Now, if you work in the VA or some other very strange, very strict environment, it could probably be about 15 minutes before you get the knock on the door and say, listen, who's on my network? I have this MAC address that I don't recognize, right? So you don't want to do that without telling your network IT guy, so we have this problem with the CT, sending to the workstation, randomly it drops images and we need to figure that out. So I'm going to connect my service PC with that MAC address for that hub. And here's my service PC. You can run your fire scanner, making sure that everything's okay. Otherwise you get in trouble, right? Okay, but the good news is that some of the PACS administrators, they're very good friends with the network people, or sometimes they came out of the network world, so they can work with them closely and get disconnected. Okay, so Wireshark Network Analyzer. So basically, what are the options? So I'll show you a little bit of options, and I will do it hands-on. So when we look at the Wireshark, we want to capture these packets, and basically we go to the options, and basically what we need to do, the first thing when you set up Wireshark. So let's say you go to the internet and you download your Wireshark. I'll show you the link at the end. So you install Wireshark. The first thing you have to do, you need to make sure that you connect that port that you're listening to. You need to make a connection between that port and a DICOM interpreter. So very easily you select Edit on the main menu. And you say go to Preferences. See Edit Preferences, and then you look at all the protocols. You select under the protocols DICOM, and you say I want to listen to port number 104. Yeah, port number 104. Right. Otherwise, it does not know, because it might take another. Might be able to, there's many different protocols, right? So you need to make sure you're connected to that particular port number. And there's some other options that you can do. One of the things that I like to highlight, though, when we do, I'm just going to show you this book. So this is the, you probably can see this, the Wireshark book. It looks like a Bible. It's like 500 or something pages or something, 524 pages. So now the good news is I only have 4 stickies. 4 stickies. So I only need 4 pages of it. But if you really want to know everything about Wireshark, oh, gee, you can probably take a class or can get certified in it. So Wireshark is very, very powerful. That's what I want to say. We only use the tip of the iceberg. Right? And I'm actually not going to go for all of the different advanced settings. I might do it in the next class or something, but it's really, we're only using the tip of the iceberg. Basically what we do, we set up the preferences and we capture and we set up a filter, right? So these are the things that we're going to do. But if you want to do some sophisticated stuff, you can set up rotating buffers, lots of other very good stuff. So this is Wireshark. When you run Wireshark, we see this on the screen. So remember I talked about Ethernet, TCP/IP, and application level packets, right? So on the bottom, we see the data, all this bits and bytes here, right? Now, the only reason I ever might look at the real data is if I look for control characters in the metadata that do not show up. And the most obvious one is the space. And believe it or not, we had problems one time that we were looking, images would not be routed to Mr. Smith. And we took as a day to figure out what's actually Smith space. And so that's why Smith is not equal to Smith space. So the images were never routed after hours to Mr. Smith space. And the way we figured it out is we're looking at the data right here. And I know by heart that space ASCII code for space is ASCII 20. I know that by heart because I have, many cases have to be able to troubleshoot it. So that's probably the only reason you ever might want to look at the raw data. Another reason I sometimes use this raw data and kind of cut and paste sometimes if I, have some other protocols. But anyway, so Now here's the second window, and what do we see here? See frame, Ethernet, Internet, TCP. So what we're looking at, we're not interested in all of the different packets, and you could, if for say, okay, if you're curious, you can click on that, you can look at it. But basically what we're looking for, we look at a TCP/IP protocol, right? And then we're looking at the top at the application level commands. So for example, if you look at this arrow, and I'm not sure what you can see, but basically this says this is a DICOM associate request from Metcom to Conquest. This is the PAX, right? And here's a DICOM associate accept, right? And there's some other junk in between, and there's a DICOM continuation, and there's some DICOM data, right? So here's at the top level, that's where we're interested, at top level, and we're looking at the TCP packets, right? Okay, so after this, so I had to just give this introduction, otherwise you might get lost easily. So what we're going to do in the next part, we're going to use a sniffer, and I'm going to show you some of these tricks and tips that we just discussed. So be able to do that, have a very cool test environment, and that is the. I have to bring it up. Yeah, this is the what we call the OTEC Virtual Hospital Platform. So it's a test environment that allows me to run different simulators, but in addition to different simulators, I can actually run also different tools. So basically what it is, it's in the cloud, right? So I just did add actually RDP earlier. So there's an RDP remote desktop into the cloud. There's actually an Azure cloud. And basically, if you look at the virtual hospital configuration, I have an EMR simulator, another entry simulator. I can send it to an interface engine, modality worklist provider, and then send my query, my CT, my modality worklist provider, send images for router to the PACS and to the workstation. So I can simulate basically a whole department, all the different modalities. And when I click on either one of those, I can just start up a simulator. And some of those are actually in a different virtual machine. Right, so it's a little bit hard to see, but everything in yellow is in the same virtual machine. For example, this blue is in different virtual machine. The PACS is in different virtual machine as well, right? So, and to go for all of the different scenarios will take us another 2 weeks or so. But so what we're going to focus on is really on looking at the modality simulator, see what the modality simulator and actually workstation and a PACS system. Those are the 3 things we're going to focus on. So let's say we have a modality simulator. In this case, it's called a OT-DICE. And the modality simulator, so we're on virtual machine 1. And basically what we're going to do, we're going to do a simple verification first. Remember an echo, where basically will allows us to set up the connection. And we do the transfer. In this case, we'll be an echo, and then a simple release again, right? So this is the simulator, and we're going to go talk to the PACS. I have another virtual machine. Let me just bring up the other virtual machine. So that we know what is going on. Ta-da, here's my other virtual machine. Yeah, here's my other virtual machine. So what we use at the PACS. By the way, what I do today is everything I do today you can do at yourself, at your home, at your office, at your business, wherever it is, because I'm using open source components, except for the simulator, right? But basically, a workstation, we use an open source workstation, and we use open source PACS. In this case, free PACS you can download from the internet. We use Conquest. Conquest is the PACS, so that will be the destination. That's what we're going to talk to with Conquest. And I kind of like Conquest because it's very easy to install. It's like literally take 2 minutes, and it gives a very nice status screen, so you can see actually what's going on, right? Anyway, so that is our destination. This is the PACS system that we're going to be talking to. So this is not a virtual machine. This is a virtual machine number 2, and the virtual machine number 1. We're going to go back now to a modality simulator, and right here, right? And so basically, before we do anything, actually, we're going to do a ping just to make sure that we have any connectivity, right? So so the PACS is in 10.0.0.4. Okay. Now remember, these virtual machines are in the cloud, and you have an internal network. So they have a public network and an internal network. An internal IP address is 10.0.0.4. So I was able to talk for my client right here, right, from a simulator. I was able to ping the packs. Always step one, first ping, make sure we have a network connection, right? Okay, so what we do next, we start up the sniffer, right? Sniffer is here. So I go to tools, and so I have a lot of tools here. So one of them is Wireshark. So this is Wireshark. I have a little bit older version because I don't know about you, but anytime there's a new version, I have to learn everything again. So I used 1.6.7 because I'm familiar, I know where everything is. But by the way, in the meantime, there's a new version as well. So when you download it, it might look a little bit different than this one. I use 1.6.7 now in this demo. So what did I tell you? When we set up Wireshark, we have to do 3 things. Set up the preferences, start the capture, and do the filter. Set up the preferences, start the capture, and do the filter. So how do we start up the preferences? Very easy. There's a edit, preferences, right? And so basically what I need to do, I need to connect the sniffer port to the appropriate protocol. So I look at the protocols, I click on protocols, and then look at how actually is amazing how many protocols it supports. I didn't even know there were many protocols. I probably know only a handful of those. But anyway, DICOM is what we're looking for. I added port 104, 11112, and 11119. Now 11119 is the one I actually added this morning because that's actually my port number of my packs. That's how I configured my packs, 11119. So we don't need to do anything. It was still there. So I know that when I do a connection to that port number, that I will be able to capture that in Wireshark. So we set up the preferences. So what we need to do, set up our preferences, then we do start. Okay, no big deal. We go capture interfaces. Now this is kind of easy because in this case, we only have one interface. See, it's running. I don't know if we can see that. See this little packets being going back and forth. And if I do start, then the stood starts calling, see? Now, if you're not familiar with what's going on in the networks, you might be really surprised, okay, wow, I don't do anything, but why is it, what's going on? What is all this talking? There's all chatter, background chatter of this virtual machine talking with the host and, making sure everything is okay. And so there's a lot of chatter typically going on, right? So you need to see something. If you don't see anything, then we're not listening, right? Or we're not connected to that interface, for example. Also, when I set capture interfaces, I showed up only one. Typically, if you do it on your computer, for example, your laptop or your other computer, you might have a Wi-Fi and a fixed connection and maybe some other Bluetooth, and they all show up there. So you need to make sure you have the right interface that you pick. If you pick the wrong interface, of course, then you won't be able to connect. So this thing is just going. It's just capturing. So it's just going nonstop, right? We haven't done anything yet. Now the next step is we're going to do a DICOM communication. Right? So we go back to OT Dice. This is our simulator. And basically I do store ICP. I select my OTAG packs, making sure that we have the right packs as a destination. See, this is Herman's packs, 10004, 11119 OTAG packs, right? Why is it 11119 OTAG packs? Because if I go to the other, to my other virtual machine, right, and I look at my packs, my configuration, see OTAG packs, AE title, 11119, port number. So cool, it should work, Okay, so server status, I'm still there. And now I go back to my sending virtual machine. And basically I just do a send of my echo send, right? So I have some local log files. I said, okay, I want to do the verification. I got receive and I get my status success back, right? So now let's look at the sniffer. I send out the information and my sniffer is still going, but again, we have all this stuff going on. So one of the things I can do, I could stop it if I want to. I'll probably leave it running because I might do some more captures later on. But if you want to stop it, you can go to the top. Actually, it's really kind of cool because when you stop and you enter a new association or a new connection, you want to do a new capture, you can save the capture file. So one of the things I strongly recommend you do some of the experiments and you save the capture file, because as you will see, it's not that easy to look at these capture files. So what is the best thing if you look at the problem file is to have something as a reference that is kind of a gold standard. So this is what works. This is how it shows when it works. And this is how it shows when it doesn't work. Okay, oh, here's what happens, right? Okay, so still listening, but I did my DICOM. So basically what I do, I go my filter on the top, filter, and I basically type in DICOM, D-I-C-O-M. So the good news is that if you type in the wrong name, see it's red, so it will recognize lowercase DICOM, lowercase DICOM, and then enter. See? Oh, super cool. So what do we have? Now remember what I talked earlier. There should be 3 phases, 3 steps. Open an association, do the job, and release. Right? So let's first look at the top, and I realize a little bit hard to see for you guys, but so I'll tell you what's going on here. So we had a time 120.73 and so on, right? And transaction number 444. There was a request from student, so the virtual machine, to OTAG packs, an associate request. The second line was an associate accept. Good. So that was good news. We already accepted. So we have made a connection. We did a echo request response, and then we release request and a release response. Wow, that's pretty cool. So everything looks perfectly fine. The next part, so we use this frame, Ethernet IP protocol, transmission protocol, DICOM. That's really, we're not interested, but we're interested in the DICOM. So let's look at my associate request. Associate request, I click on the top, and I'm going to click on all these pluses. And I see now that what happens is part of the negotiation, there was a verification subclass proposed with 1, 2, 3 different transfer syntaxes. Implicit via little endian, explicit via little endian, and big endian. Which was the way it was being configured. Right? And the PUDU size what was proposed was 10,000, and the implementation class UID 216.124 that implements, that really identifies the sender and then the version number. Okay. So what is important, remember when you look at it at a communication, there are 2 critical junctures, whether information is accepted or not, right here. And was it accepted, right? Yeah, it was accepted, right? Otherwise it would say reject, right? So basically it was accepted. And in my C echo response, the status code, right? So my response, my status, success, 0. So everything was fine. Very simple. So you should first do the verification so you get an idea of the what's going on and really of the 3 phases. So now we can do anything we always will. So let's do a workstation. That would be kind of fun, right? So we have a radiology workstation right here. And so basically I use Clear Canvas. It's free, open source, easy to use, has a very nice help file. Yeah. So very good as a, I use it for my, for my home use, so to speak, right? Because it's free. So what I did, so this is Clear Canvas, is a workstation, and basically here Herman's packs. I selected the packs, right? Selected the packs. So this is the search, and I'm doing a search. No, actually, what I'm going to do first, I'm doing again a verification. Remember, we just want to make sure everything is okay. So do verification. It's right here. Echo success. Okay, cool. And now do a search. So I click on search. It says, are you really sure that you want to do that? Because it might take a long time. Say, sure. And I get 1, 2, 3, 4, 5, 6 responses. Okay, what's happening over the line? What's happening over the line? Okay, so happens here. So my first echo from a simulator. Right? Now I have my second echo. This came from a title from my workstation. Was accepted. I did my verification. See echo request, echo response, release request, release response. Huh. Another release request. So one of the things that you sometimes see, you get sometimes bonus. I call it the bonus. So at the end of the whole cycle, as long as you've established in the communication, do your job and nice release. If at the end somebody says, okay, just want to make sure I do another release or something, or another abort or something, nothing wrong with that. It's just the implementer said, I just want to make sure everything is disconnected. So you might see sometimes bonus, I call it the bonus, a command at the end, but you shouldn't be worried about it. Of course, if it's in the protocol sequence, then we should worry about it. Yeah? Okay, so that was the verification from the work list, from my workstation. Now I did my associate request for my, for my AA title to PACS, associate accept, right? Now what was requested this time, right? And this time I did a study root query retrieve information model find. So basically I did a query. Remember I did search? I did a query, right? What would I expect in a query? Well, if I go back to that workstation, I probably would expect a query of all of these attributes to be filled in: patient ID, last name, name, date of birth, accession number, and so on. So all of these attributes I would expect to be in my query request, right? Let me make it a little bit bigger so we can see it better. Okay, let's go look at it. So I had my cfind, so after it was accepted, I did my cfind request, right? The cfind request right here, and got a response back, and then I got my data. Right? So I got my first data. Sure, yeah, I got my accession number, and I got my study, I got the name, right? Patient ID and patient birth date, study instance UID, very important because that allows me to pull over the study if I like to retrieve it. And then what's the status? Pending. So it says there's going to be more coming. Okay, then we get my next one. Okay, we got here CT, right, with this name. Status pending, right? The next one. Let's get another one and another one and another one. And then all the way in the end, right? Get a pending, then we get the success. So that's the cycle for a typical workstation query. Yeah? Before I go to a little bit, I want to make sure that I want to that I kind of simulate some typical errors as well. So let's go back to the simulator, to the modality simulator, and see whether we can simulate some errors. Here's my DICE, and what I'm going to do, I'm going to send an image. And so when I send the image, I do store SEO. I want to send it to PACS. I do a clear first, and I choose my image. I do a CT image, right? Open. So in my send list is a CT image, and also a dose structured report from the CT. This is my send list. So nothing happened yet. I just selected those two images and a CT. Close. Okay, so no problem. I send it to the PAC system. I'm still listening, so store, send, right? And okay, so what is now the communication? Say it. What is this communication that goes back and forth? Okay. So here's my, now, of course, you see much more packets because this is an image, right? We see all this pixel data going back and forth. Yeah. So again, first my associate requests. What I'm proposing now, I'm proposing in my associate request a presentation context for a radiation dose subclass and a CT image. Okay? Okay, so now in my accept, what's happening in my accept? Okay, so my accept says, okay, sure. I accept my CT presentation context, but I do not accept the presentation context for my structured report because it says abstract syntax unsupported. Remember when I said what you're looking for always at the accept for the association if there's any errors. And indeed it says abstract syntax not supported. I'm not going to accept it, right? And as if we can go back to, for example, my simulator, we will see We'll see in the center, this is still in the queue. Still in the queue. So that didn't make it. Right? So typical error of when we try to send something that is not accepted, and you will be, now and again, at your modality level, there might be something like DICOM error. Now we can see exactly what's going on. Say, oh, this technology is trying to send a dose report to the PACS, and those reports are not supported by the PACS, or maybe it has to be sent to your dose management system, or maybe the dose report has to be not as a dose report, as a dose DICOM structured report. Maybe we need to do it as a screen capture at the end of, whatever. Now we can, after we find out what the problem is, we can start figuring out how to solve it. But if you don't find out what the problem is, you have a problem. Now, this is very, very useful. I actually I hear quite a, people that I hear that struggled for a day or so, that they couldn't figure out why does the modality not talk to the PACS, and then they find out that they, for example, select the enhanced MR instead of the regular MR, or the enhanced CT instead of the regular CT, or they try to send private Philips or GE or Siemens ultrasound images that not supported, right? So that part is very, very important. So watch for that association accept coming back. That's the first error. The second error or potential error would be right here, right? Remember, all the way on the end, So C-store response, right? C-store response. So store response, right? And my C-store response, I got a processing failure. Yeah. What does that mean? The PAC says something, okay, I have a problem. Even although you set my your C-store, and the whole information went back, but I didn't process it correctly. Now I can go back to my PAC system and say, what did it complain about? Right? So let's go look at the PACs. What says it here? It said refused to enter inconsistency series instance into the DICOM image patient ID, error saving to SQL. So the image that I was trying to send had an inconsistency. It was already in the database with a different information. So it says processing error. So this was a very good demonstration of two simultaneous error. One of the presentation context that was not supported, was it rejected? And the other one was, we will not be able to accept this image, right? Okay, so I think, I want to kind of close this up, and I think, you got the flavor with it, play with it a little bit. So let me make some closing remarks because I want to make sure I have some time for questions. And I mean, I can spend probably 2 or 3 hours more on Wireshark, but that would be good for another session. So let's go back to the slides and see where we left off. So, what are some of the issues regarding Wireshark? First of all, the information doesn't show up on your Wireshark scheme. It's almost always the port number. It's not connected, or you did not connect to the right, you didn't capture the right interface board, the right NIC card. So make sure you connect to the right NIC card and the right port number, right? So that's one of the probably the number one issue that the people say, okay, I don't see anything. Now, the second problem is probably even more of a problem. Where do we connect the sniffer? If you need IT cooperation, you kind of just pull a cable and connect it to your whatever hub, and right. So what a lot of vendors do, for example, I did a training class of one of the vendors that they make endoscopy equipment, and when they install it, every system they install, they have a sniffer, because you never know. He said they never know. Maybe we use it once a month, but if you need it, you really need it. And after that, so they have it at the source. Now the good news is that they have a Windows system and they could run it there. At the source, and then after, when they leave, they actually, most of the time they take it off, or they just leave it on, so in case they might remotely log in back in. So perfect will be at the source if your vendor allows you to install it at the source, right? Or you can do that at destination. Let's say you have a VNA, and the reason that I like kind of one of the advantages of the VNAs are typically more open to having you put other software on, right? So if you have a good VNA vendor that you're good friends with and it runs Windows, you can put it on the VNA. That would actually be perfect, because you can listen to anything going on. So you can actually run it on the VNA. So you can either on the source or the destination or in between. Now, if for some reason you cannot go either way, then talk to the IT department, because they have sniffers running anyway. They have sniffers running from on their big routers, the network management system. So the good news is that the files that you capture are standardized. It's .cap files. So you said, can you capture for me the captures from this IP address to that IP address, right? From 9 o'clock to 11 o'clock, because I'm going to do an experiment. And then would you mind giving me the capture file, and then you upload it into Wireshark, and you basically do load, and then you can actually look at all the information. That's a very common practice as well. For example, when I do troubleshooting, if I get a call, said, Herman, we have this problem. I said, okay, send me the sniffer file. So they email me the sniffer file, of course, after I write my BA agreement to make sure that I keep everything confidential. Because remember, what you see is the data, right? I mean, I can go back to this particular image, and I can show you all the metadata in the header, right? It's right there. But anyway, so you can actually take this capture files and open it back up into your sniffer and then do the investigation, because the cap files are generic. Now, where do you want to, if you have a random issue, what does random issue meaning? Random times between, I don't know, 8 o'clock and 10 o'clock, 2 or 3 studies are randomly sent incomplete. And I've had that happen, right? So every morning there's a couple of studies that are incomplete, but you don't know, because I've sent my study, oh, now it's complete. I sent the study, it's complete. You have to wait for it forever and ever and ever. So what do? You set up a rotating buffer. So you basically capture, and after the buffer is full, it will automatically overwrite it. So you can set up a Wireshark, you automatically rewrites and rewrites, and then you find, okay, oh, problem, stop. And they capture that information, right? Now, another thing that's very useful is if you have this big data stream. So for example, I get an email, so we have this problem, and I say, send me the capture file, and I get 10,000 transactions, I mean, there's no way I can go through it. So you can use the filter. You can filter based on destination, port number, source, right? So you can be very specific with the filter. And that's one of the pages that I need for my Wireshark book, how to set up filters. But actually, I was just looking this morning, if you go to YouTube, how to set up Wireshark filters, there's a couple of examples, so it's relatively easy to do, right? So, in summary, what did we do? We talked about Wireshark. Wireshark is very powerful. If you need it, you really need it, right? People that are really the second or the third level support, everybody has Wireshark, right? It's a passive test tool. It doesn't impact performance. That's good news. But the challenges are where to install it. If you go into the VA or a very strict environment, the Department of Defense or the Navy, yeah, you have to make sure you get cooperation, because you want to make sure that you are allowed to install it at the particular site. And then how to sift through the data is sometimes a little bit of a puzzle. You need to make sure you have the right filters. But it's nothing else than using Wireshark, having the ultimate proof, because it will say, oh, why did you send to your board? I didn't send it to the board. Well, it's right here, right? Another thing I didn't, use it to, one of the things I want to say is use it to practice. Download Wireshark, download ClickCanvas, download, put it on the computer, put on Conquest, and practice. Do some of these captures and archive them, because if there's a problem, you can compare with what we call the gold standard. So, okay, we can see exactly the cycle. For example, when I went through this very quickly for this find request, if you know exactly what it's supposed to look like, if there's a problem, you can go back. So in conclusion, happy Wiresharking. So I want to show you, by the way, some resources. So you can download Wireshark, of course. I actually have another video on YouTube about how to use Wireshark. You go to OTech YouTube. And now, when you look at the log files, it might be a little bit overwhelming, because it talks about abstract syntax, presentation context, transfer syntaxes, subclasses, and so on. So I have a little book on DICOM, so you might want to look at it. If you're too confused and you need to have some references for all this terminology, you might want to get the book. Stay in touch. There's my information on the bottom. And I think, Bradley, we have 5 minutes for questions.
Absolutely. Well, thank you as always, Herman, for such a phenomenal presentation. First question, can I have my network team do the capture for me and then analyze it with DVTK afterwards?
Yeah, you could do that. So basically what you do is you have your network team captured. And then, so what is the advantage of DVTK? DVTK is a validator. So let's say something was wrong. Let me give you an example. We had an issue where the work list didn't show up on the ultrasound. And the ultrasound was one of the top 3 vendors. And of course, you call them and says, okay, well, it shows up everywhere else, so it's your problem, right? So I was working with a risk vendor. So they were pulling the workstation, the work list from the risk vendor, with a modality work list provider, and it showed up empty. So basically, we had to use Wireshark. We captured the modality work list response. We put it in the validator, and the validator says, this information in this field is not valid. So what happened with the ultrasound? The ultrasound said, oh, I gave up because this value is not valid, so I'm not going to display it. So using DVTK, using a validator together with the capture is sometimes very, very useful, because I would say 80% of the time I can see what's going on, but 20% of the time, I don't know. I don't know what all the allowed fields are for whatever body part and things like that. Or sometimes, the procedure code might be incorrect. So yes, you can use it with DVTK. DVTK is a validation toolkit. You can download, again, it's open source, it's free, and you can run your validator. Next one.
Awesome. I'm looking on Amazon and I cannot find a hub. Can I use a switch instead?
Yeah. Oh, no, you have to use a hub. Well, you need to go. I'm sure you just do some more finding. When I went to Amazon, I could find it. Or you might have to ask some of your IT guys, so do you have a really, really old hub? Because when we started, before we had the intelligent switches 20 years ago, people were using all these hubs. I have one. I can sell it to you. No, but basically, you go to Amazon. You can find it. Just network hub or something. Yeah, but you have to go to Amazon. Because every port is listening to every port. You won't be able to get it from your Best Buy or something.
Okay. Let's see, another quick question. Just to clarify, you recommend to connect, say, at the hub, but where would you connect the sniffer for a portable unit, such as a portable ultrasound?
Oh, so portable ultrasound wireless. So basically, what you have a laptop, and you can actually connect wireless. Oh, yeah. So you need to make sure that you can connect to the wireless network. So you had authenticated. So there might be security issues. Yeah. So you need to connect to that wireless connection. Now, if you let me one very small, quick kind of a interesting thing. So when I was teaching this class in Boston, I think it was Boston Children's. Well, maybe not. Maybe I shouldn't mention that. But anyway, I was teaching this class, and somebody said, so I said, did you ever use Wireshark? And one of the guy in the back said, yeah, we use it all the time to listen into the communication of my college girls, friends, and whatever it is. So I basically takes all of the information, and basically you can see exactly what's going on. Anyway, okay, go ahead.
All right, I think one last question here. Are the DVTK tools free?
Yeah, you go dvtk.org, or you do DVTK DICOM, and you can download them. And there's some, it's very, very useful. Very useful. Actually, I have another video. If you go OTAC YouTube, is how to use DVTK for validation. Yeah, maybe there should be. I think there should be another IIP tips and tricks. Right? Let's do that.
I like it. Well, awesome. Thank you as always, Herman, again for such a phenomenal presentation. For those of you who are SIIM members, we're pleased to offer 1 hour of SIIM IIP credit for attendance in today's session. And in order to claim that credit, you'll want to fill out the post-webinar survey that will open at the close of today's Zoom session. Alternatively, that same survey is going to be emailed to you tomorrow morning. We're also excited to announce that the SIIM 2021 webinar series will focus on enterprise imaging. This series, sponsored by Barco, will cover topics including cybersecurity, cloud-based image management, data migration, and the role of telehealth across the enterprise. The series will also launch directly from SIIM-U, featuring a new interface experience and streamlined IIP credit award. We're excited to share this with you in the coming weeks, and you can stay tuned to the usual SIIM channels for information on when registration opens. Herman, thank you again for the series, and we look forward to new topics in the future. Have a great day and a fantastic week, everyone.
Take care. Appreciate it.